my name is Chantel, and welcome to another Aldeck Riviera-PRO video. In this video, I'll be talking about how to save your waveform configuration and how to save a waveform snapshot. Knowing how to do these two things is important because it allows you to easily retrieve the configurations of what you are looking for in your waveforms, and will also come in handy for when you want to compare simulation datasets. So I already have this VHDL frequency meter example design loaded up, which you can find under VHDL inside of Riviera-PRO's example folder. I'm going to execute the project runme macro to get my waveform simulation results, and then I'm going to switch over to the documents perspective. Now with all the test vectors simulated, I'm going to use some of the waveform tools to mark and sort this simulation waveform. I'll just add a couple of cursors and have them marked at different simulation times. Next, I'll create a virtual group for all the actual LED signals and relabel it. And lastly, I'm just going to add a couple of bookmarks at two different simulation times. So as you can see, it would be kind of tedious to repeatedly configure your waveform like this every time you want to run your simulations. So this is where saving a waveform macro comes in handy. While the waveform window is up, head over to the Waveform tab in the main bar, and then click on Save to Macro. I'll rename the macro and click OK. And now what this does is that it takes all the user-defined properties you added into the waveform and creates a do macro file that will add the configurations you saved into your project's simulation waveforms. I'm going to go back to default perspective and notice now that the macro has been saved into the frequency meter example folder, as you can see in the File System tab. As you can see, the macro file contains commands that add signals into the waveform, and you can also see that the same add command is used to create the virtual group for the actual LED values using these arguments. Below the add commands, we can see this WV command, which means waveform viewer, and followed by the period are keywords such as cursor to add the cursors that I made, bookmarks to add bookmarks in, and even zoom to zoom the waveform viewer window to the time range the simulation was left at. I'll go ahead and close the waveform window and show how to use this macro. Go to the project runme macro, and underneath the line where it initializes the design, I'm going to comment out the line that adds signals to the waveform viewer. And then I'm going to add the command line do example.do. Then I'll also comment out the run command, save my changes, and then click on execute macro. And there it is. All the configurations I made to the waveform are there. Once I hit run, the simulation results will appear on the waveform along with the cursors, bookmarks, and virtual group that I had added in. So we now have the user-defined waveform configs, and we also have our simulation values. If you want to save both of these, you would just need to save a waveform snapshot. To do this, go back to Waveform and then click on Save Waveform Snapshot. I'll rename this to example_snapshot and then click OK. When you do this, the AWC file gets saved along with the full history of signal values getting saved into an ASDB simulation database file. And with the new snapshot saved, you can load it into the dataset viewer. I'll switch to the debug perspective, click on the datasets tab, and then right-click to add my new dataset. You can load as many snapshots into your datasets as you'd like. From here, you can access the different datasets and utilize the objects viewer to see how your simulation results can differ from each other. You can also right-click inside of datasets and click on Compare to perform a comparison analysis too. There's so many things that you can do with your waveform simulation, And being able to save your configuration makes it a lot easier to find what you need from multiple simulation runs. Along with that, you have your waveform snapshots that you can use to view and compare different simulation runs. That's all there is for this video, and thank you for watching.